What's up, interview hackers? Sam here from ByteByByte.com, and in this video, I'm going to show you how to solve the max sum subarray problem. And if you haven't already, make sure you hit that subscribe button and the notification bell to get notified every time we release new videos just like this. All right, in this video, we're gonna look at the maximum subarray problem. And so in this problem, we have an array and we wanna find the contiguous subarray within that array that has the greatest sum. And specifically, we actually wanna figure out what is the sum of the greatest contiguous subarray. And so I'm not gonna go through all of the details of the exercises that were in module 2. I would encourage you to look in the workbook because we have written explanations for a lot of the specific stuff, but I just wanna cover the problem as a whole to make sure that you understand what's going on here. And so with this problem, we're given an array of numbers and we're looking for that contiguous subarray. In this case, we can see that our, you could test this for yourself, but this is going to give us a sum of 6, this subarray here. And so that's going to be the greatest subarray in our entire list. And so let's start here with defining what our function is going to look like. And so in this case, it is important for us to make sure that we're properly defining the function because it would be really easy to think, okay, we actually want to return this subarray. But that's not the case, and that's not what the question is asking. The question is actually just asking us to return this number here. And so what we're going to do is we're going to write a function. So we're going to, something like, max subarray. And all it's going to do is it's going to take in an int array and it's going to return an integer. Right, and so that's all we have to do here for our function definition. And now let's look at what would be a brute force solution to solve this problem. So hopefully you're starting to get comfortable with the idea that most of the time our brute force solution is going to be to find every possible solution, right? And then we can just consider of all the different possibilities, which of those possibilities actually gives us the best result. And so in this case, it's pretty easy for us to do that because all we have to do is we're not even looking at all the combinations, we're just looking at the different subarrays. And so we can just use a nested for loop. We don't have to do any recursion or anything complicated. We're just gonna say, for I equals 0 and I is less than the length of the array, and I plus I plus plus. And now all we have to do is say, for j equals 0 and j is less than I, j plus plus. And for each of these, all we're going to do is, max sum equals the maximum of the max and the sum of the array from j to I, right? Because j is going to be less than I. And so in this case, all we're doing is we're just saying, let me consider all the different possible subarrays. I'm going to sum up each subarray, and for each subarray, when I sum it up, I'm going to compare that to our current max. And so that would look like, I'd start with, okay, I or j and I, something like this. I'd say, my max is equal to -1, then I'd increment I, and so I would get that my max is now going to be still -1, and then I would increment j, and we would go on like this indefinitely, and we would go through the whole array. Right, so that's how we would do this as a brute force solution, and of course we want to ask ourselves, what is going to be the time complexity and the space complexity of doing this? And so in terms of the complexity, because we have this nested for loop, and even though we have this j, I always found this really confusing. When j is less than I, rather than j also going to the length of the array, because it seems like, is it actually going to be O of n squared? But the answer is that it is when we have this nested for loop, we're going to have a time complexity of O of n squared. And it's really actually, I believe that there is a video in the bonus section of the course on big O notation and stuff, and we cover a bit more why this actually is that way. So if you're not sure you understand the logic behind it, go check out that video. But we're going to get a time complexity of O of n, and then we're not really using any extra space here, and so our time is O of n squared, and our space is O of 1, because we're not using any extra space. But now the question is, can we do this in a way that is going to use less time? And, you know, from a logical standpoint, it doesn't seem like there's any reason why we wouldn't be able to do that, right? In terms of our best conceivable runtime, the only thing that we have to do here is that we have to iterate over the entire array. And so as long as we're iterating over the entire array, we know in theory we could figure out the answer. And it's pretty clear as well that we're doing a lot of extra work here. So like, let's think about how we could start to optimize this. Well, the most obvious thing that we're doing that's a lot of extra work is that we're computing this sum again and again. And what that means is that we're summing up pieces of the array multiple times. Because let's say that first I look at this subarray here, and then I look at this subarray here. Now I'm actually summing up this piece 2 times. I'm doing it both times when I compute it. And so obviously that's taking us extra effort. And so we don't need to, theoretically, is there a way that we could do this without summing the whole thing multiple times? And so when we look at this, you know, I'm basically looking at that. And then the other thing that I'm noticing is, let's think about, like, are there any restrictions on like what our possible result could be? And so I think that we can all agree that one restriction on our result is that the first element and the last element of our maximum sum array are never going to be negative, right? And I want to clarify that for a second. Like, let's look at this here, and let me erase some of this stuff. So I'll rewrite this in a second, but just while I'm erasing this, I want you to think about it. Like, what would it mean if one of the numbers at the beginning or the end was negative? So we have 2 on -3, 4, -1, et cetera, et cetera. And so I want you to think about, like, what would it mean if, for example, the first element was 2 or -2? Well, that would of course mean that, let's just compare this subarray versus the one that doesn't include the 2. In that case, we know for a fact that this smaller subarray is guaranteed to have a greater sum than the one that includes the negative number on the front, right? Because the negative number is basically forcing us to have a lower, to decrease the actual sum of that subarray. And so we know for a fact that our subarray is not going to have a negative number at the beginning and end. And then more than that, we can also, you know, extrapolate that when we're looking at the subarray and when we're summing up the whole thing, if there's ever, it's not just about a single number. If there's ever a subarray for whose sum is negative, we never want to have that subarray prepended onto our resulting array, because it's always going to negate the full amount. And so, or it's going to subtract from the maximum. And so that's never going to give us a max. And so let's think about what that looks like here. So our array, if we look at this, we are never going to have 2 be the first element of our array, right? Because or -2 be the first element. We're also never going to have 1, 2, or -2, 1 be the first 2 elements, because if we did that, then that would still mean that it was negative, because the sum of these 2 is going to be -1, and so it's going to decrease the total. We would never have -2, 1, -3, and so on and so forth. We're never going to have anything that starts here. We may, though, have something that starts with the 1, and I'll do this in green instead. We may have something that starts here, because this is going to be positive. And so we could have something that starts here, but we're never going to have anything that includes these first 2. Oops, let me do that in red again as well. We're never going to have anything that includes the 1 and -3, because that's also going to negate our total. Right, and so we could have this 1 by itself, or we're going to skip ahead, and we're never going to have the 3, because the -3 is negative again. And then So we're never going to have anything that starts there. And so we basically have now taken this first section of the array and we say that we either have this one here and that's it, or we know that our resulting array has to start at 4. So it could start at 4. It could start at 4, -1, because that's still going to be positive, right? That's going to be 3. It could be 4, 2. 4, -1, 2, because that's also positive. It could be 4, -1, 2, 1, because that's going to be positive, right? We're going to have 6. It could even be 4, it could start with this. It could even include the -5, because this is still positive. The sum of this whole thing is 1, right? And so if there was a lot of stuff here at the end, we might want to prepend 1 onto the rest of that. And then finally, it could be this whole thing, because all of these are positive. And so let's look at, when we look at this, what we're basically seeing is that to figure out, and then we're basically like, if we wanted to actually figure out what the sum was, let's look at we can basically compute the sums here, right? We have 4, we had 3, we had 5, we had 6, we had 1, and then we had 5, right? And so that was for each of these arrays. And because this 4 at the beginning is positive, we know that no matter what, if one of these is our resulting array, it's always going to start at that 4. Because if it didn't start at the 4, we're subtracting 4 from all of these values, right? And if we're subtracting 4 from the value, so we're no longer at that maximum. And so what does this actually mean? Because I'm sort of talking very hypothetical here, and I want you to understand how this is actually going to translate into code. And so basically what we're looking at here is that we know that every time this prefix is negative, we're going to exclude the prefix and start from 0, essentially. And so the way that we can compute this is actually very, very simple. It might look complicated here, but it's actually super, super simple. And all we have to do is essentially compute a running sum. But when we compute our running sum, anytime that running sum is negative, we reset the running sum to 0. Because that's the equivalent of saying we're going to exclude the beginning and we're just going to pick up from here. And so I want to show you what this is actually going to look like if we were to compute the running sum. So for this, our running sum is negative. It's going to start at -2, and what we're saying is anytime it's negative, we reset the running sum to 0, right? Because we exclude that beginning. So we get 0. And like if you consider this as an array where it was just -2, then the sum should still be 0, because we would want to include no elements, because the maximum is going to be 0 in that case if they're all negative numbers. And so that's why, we'd have to clarify if, for example, there was a requirement that our input or that our output included at least one element. But based on the way that the problem is defined, there's nothing saying that we can't have an empty array, and so 0 is sort of going to be our default. And then the running sum continues. So now, because we reset it to 0, now we're going to add 1 to that. And remember, like we were talking about this before, an easy way to think about this is just like, what if our entire array was just this beginning part? And so if it was just this, then it makes sense that our sum would be 1, because we would just include that one element. Now we continue with the running sum. -3 makes this negative again, and so we're going to reset back to 0, which is what we were talking about in this section. Now 4 is positive. -1, it's a negative number, but our result is still positive. And so we continue computing the running sum. So we get 3. Then we get, we have 2. And so let me actually try and line these up a little better. We get 2. So 3 plus 2 is 5. And then 5 plus 1 is 6. 6 minus 5 is still positive. So we get 1. And then plus 4 is equal to 5. And so you can see that it lines up with like these numbers that we had computed here is basically what we have in this. And then, let's say that we had a couple more numbers on the end. Like let's say that we had, let's just add 2 more numbers. So let me say that we had -10, and then we had 100. So now what would happen is that we would be going through our array and we would get to -10. And so we would reset to 0 because this would take us to -5. So we'd reset to 0 and then the 100 would become 100. And so now in this case, for example, essentially when we were looking at our arrays here, we're going to say, okay, we got to this 5, but then as soon as we include the -10, now that is no longer positive. Right now, we no longer want to prepend this onto the 100, because if we prepended it onto the 100, then we would actually get only 95. And so we're going to reset to 0, and then we get the 100 at the end. And so hopefully this makes sense, but this is basically the framework that we're going to follow here. And I hope that you see with this, what I really want you to take away from this problem, more than specifically how to do it, is like how logically I was thinking through the problem. Because it's not about what is the solution to this problem. Remember, it's super important that we're not memorizing solutions here. We're really focusing on like, how do we understand what's going on and how can we recreate this in the future? And so hopefully that made sense the way that I walked through it. The code actually, as you can see here, once you understand how to do it, is super, super simple. All you got to do is just basically do a for loop, and that gives us an O of, and we're just summing everything once, right? We eliminated that repetition, and so we're going to get an O of n time complexity here, and our space complexity, we don't actually need to compute we don't even actually need to compute or store this whole array of running sums. We can just keep the current running sum and what the maximum is. And so with that, that's all that I got for this problem. Again, we'll include the code so you can take a look at that as well, and I look forward to seeing you in the next video.
Thanks so much for sticking with me to the end of this video. If you enjoyed this and want a ton more like it, go over to byte.com/50questions and you can download our free 50 coding interview questions guide, where I'll take you through 50 of the most common coding interview questions. And if you like this video, make sure you subscribe and hit like, because it really helps us with the YouTube algorithm.